We are back once again for some daily LeetCode. As you can see by my lips, their texture resemble the Saharan desert. So that being said, we are back once again and we have some comments. We have Thomas Wong coding, the legend, the man, the myth, the prophet, Thomas Wong. Haven't dropped by in a while. Good to see you going strong. As always, you too, brother. Check out your channel. I am in love. Make sure to check this man's channel out. This is the GOAT. Just all around good dude, man. So yeah, I was looking at it was just cool to see. I don't know. Yeah, meeting people on the internet feels strong, man. So yeah, make sure you guys check out T Wong the God. And we have JD, hey Manny, new to your channel and coding, currently in uni studying CS, and I want to know if you could give me some advice on staying motivated during the whole process. Tend to feel behind when compared to others and my peers. This is pretty deep. Yeah, I don't know if it's just today, like the time we live in, that has made this process of staying motivated very complicated. But maybe the pioneers, maybe the apes, maybe when we were monkeys, it was still that difficult to stay motivated. Maybe staying motivated, if it's outside of some primitive aspect of evolution, maybe it's just impossible. Or maybe we have to weave in some of those aspects. I'm not really certain. But I know that it is definitely hard to stay motivated. But yeah, I feel like it's so complicated. Motivation, what if I'm going to steal words. What if I'm going to steal words from Gabriel? I'm going to steal words from Gabriel. Let us consider motivation as a conduit for ignition. What if instead of you seeing motivation as the fuel which drives the vehicle, we see motivation as the mechanical motion of starting the car? That way, I think it's easier to see. I think it turns out to work easier that way, just because motivation feels very transient, ephemeral. It feels a lot like a bellowing fire that, massively expands and then quickly compresses. And maybe it's impossible to sustain an engine a long time on motivation. But I do think you consistently need, the way the car analogy works, I do think you do need some consistent source to pretty much get in the car and turn the key. And I think if we view motivation like that, I feel like it's much more useful. So what if instead of saying how to stay motivated during the whole process, we ask ourselves, how can we stay motivated to start every day? So I'm mostly just stealing words from Gabriel there and trying to sound deep. But I would say all the nonsense words I set aside, I would say this is how I see it for myself. It seems like focusing on starting is an easier way to make sure you go further. But tending to feel behind when compared to others and my peers. There was another book about this. I think it was How to Learn. I think it was called Overlearning, and pretty much it was about learning a lot of things. And I think the author does mention some people do have a proclivity towards. I'm not sure if I'm using that word right. A proclivity towards competition. I feel like I tend to be one of those people, but I feel like a lot of people in CS tend to be one of those people. But the issue with CS, there's a lot of gods in CS. The generation of miracles is very much alive in the CS area. So one way, I guess, when competition feels like you're unable to be matched, one way is to create a very specific competition. For example, if you compare yourself just to everyone in your class, just based off you're all taking the class, it's a little bit tough, right? Because you don't exactly know what everyone else is going through, what you're going through. But what you can do is give yourself a very specific challenge so that the only person you can compare yourself to is yourself. So you could challenge yourself to do some amount of programming every day, uh, in your like specific schedule, you could say something like, I'm going to do like this, like I'm going to build an app on the side while I'm working on my, studying in CS or something like that. That way, when you compare your peers, you can say, my peers may be doing better than me, but I'm also working on something else on the side. So you might be a little less harsh on yourself. But I think that's one of the tools he mentioned in the book on how to do that. But that was a very bad example. Basically, it's to find a very specific competition that you can enroll yourself in, so that the pool of the competition is a lot smaller, so you can feel like, you're doing better. Another way is to say, it's hard to find all these things, but yeah, it's tough. Just one thing that made my thinking easier about being motivated about the process. During a long process, one cannot stay motivated for a long time, but staying disciplined for the time you feel motivated can help you remain disciplined throughout the process. Go for discipline rather than searching for constant motivation. Hope this helps. We have some wise words from Aditya Singh. Hopefully I'm saying that correctly, but it is important to try. And yeah, I would say I agree. I guess I would say maybe we're saying the same thing. I guess I'm thinking that maybe if we focus on starting, it's crazy because I struggle to start new things as well. And I've been doing this for a little bit, but every time I try to start something new, I end up going through the same motions of overthinking when I should just get started. It's just crazy how much even just getting caught in the human thought loops is crazy. But yeah, maybe a focus on starting more. I think maybe if we focus more on starting and less on maintaining, we'll end up maintaining. So it's kind of a weird thing where to get B, so there's A and there's B. To get B, we feel like we have to focus on B, but it feels more like if we focus on just starting, we in a weird way, we sort of as a symptom of always starting, we kind of end up maintaining. And then C, I feel like after you've been doing it, after you've focused long enough on starting, I think it just starts to feel like another part of the day. So yeah, I think, it's a strange thing. When I first started the challenge, just starting LeetCode was so difficult. Now we haven't solved many problems, but just starting was hard. Now it's a lot easier to get started, which is really good because now it doesn't feel very difficult to get started. So I never really have to think too hard about starting. It's just easier to just be like, I'm just gonna go do LeetCode. But yeah, I would say it is good to get exposure to starting the engine frequently, because it's very difficult just to get in your car and start the engine. So maybe if we focus on that, it'll be easier to get where we want to go. But I forgot where I was going. Yeah, it's been hard. It's gotten easier to start, but yeah, hopefully after it's gotten easier to start, it's not really hard to think about doing it, which is good. So then the question becomes, using your time effectively when you're actually doing LeetCode. And that is the other battle. So that being said, we are slightly low on time today, and we have to get started now. So we're going to be doing 50 minutes today. 50 minutes, because I actually almost didn't make it to my upload timer. In fact, we're going to be doing, we have to do 50 minutes, actually. We have to do 50 minutes. Schedule's just been a little tight. I just finished rowing. So we're just going to jump into it. Today is day 129. I also promised the Discord bot. That's almost done. I also promised a 100 days of LeetCode video. That will also be done soon. So it will be done soon. And we're going to jump into it. And hopefully we can continue to make progress slowly. So we are back once again. We're doing a problem called build array from permutation, where you pretty much had to transport an index. We had to produce an output array given a zero index unique integer array, where all the indexes all the numbers in the array are valid numbers between the range of the length of the array. So 0, exclusive of the length, 0 to 6, 0 to 7. And what we had to do was basically rearrange the array based off of the values in the indices. So at place 0, we have to place the element in index 0 in the array. So we place 0 here. Now at index 1, right, in our output, we have to put the value of index 2, which is actually 1. 0, 1, 2, we end up with 1 here. Now for the value at 1, we have to place the value at 0 in the array, which is, at 1 in the array, which is 2. So we get 0, 1, 2. And it's easier to see with this example. At index 0, we have the number 5. So we have to place the value at index 5. 0, 1, 2, 3, 4, 5 is index 4, and we end up with 4 in the output. You can solve this problem by using space in linear time with linear space. The follow-up was, can you solve it without extra space or with constant memory? And I think the cheat code is because the length is the value, the maximum number of the value in length is 1,000, which means using bit logic, we can store. So yeah, using bit logic, we can store 2 values in the same spot. Except to get the number out of the value, we'll have to decode it. So we wrote some functions called encode MSB and decode MSB to pretty much encode some bit values into the number. And that is the goal. So an example is we have the number 5. We encode the value 512 into the bit space of 5. We print the bits. You end up with a nonsensical value, basically. Oh, you end up with the largest value, right? Because it's pretty much 512. No. I'm also just now realizing something, why this code is not working. We're calling this function encode MSB, so we're passing the number 5, and for the value 512, we want to encode that into 5. But in the top half of 5. So you can see here, we would have something like this, where 0, 1, 0, 1. I just realized people can't see my mouse. Or maybe they can. We have 0, 1, 0, 1, which actually represents 5. We want to encode 512, which would just be 1 bit turned on, the bit representing 512. So print bit, so this does look right to me. Now if we decode the MSB, we get 512, which is exactly what we wanted because we encoded 512 within this value here. Now if we decode LSB, we get 0. And that was something I failed to realize. If we decode LSB, the value is wrong. We should be able to get 5 out of it. So before we can even write this function, decode LSB should be giving us 5. And LSB and MSB just stand from the direction from which we pull the numbers out. MSB being the high end of the bit range where we'll store the secondary value, and LSB being least significant bit because we store it near the right hand side. So decoded would be equal to 0. We'll say decoded equals num and 1. And then we bit shift it once to the left, and then we bit shift num equals . I think what we want to do instead is do something like this. I always do num and 1, but I think you just have to add 1. No, that's not it, because we're getting 640. So I'm going to make sure we return an empty array here, just so we can stop up here. I just want to process these first 9 bits. Also, we definitely don't need to do 64 to print the bits. We can just print the first 20 bits. Or make it even simpler, we can just print the first 18. And then alright, print bits for decoded. Oh, I think I see what's happening. So now I think it's actually working. Except we basically stop in retrospect. I'm realizing now it'd be easier to decode LSB if we just calculated the value in there. What we're doing here is trying to copy it, but we end up pushing everything. So one way I think we could keep the code is if we just bit shift it the other way, and instead of doing num ampersand 1, we would just do num ampersand 2 to the 9th. 2 to the 9th is 512. So we just do num ampersand 512. That way we'll get like some kind of 0 value, right? It'll be 0, so you right bit shift right, 0 bit shift right until we get these numbers slide all the way down, and they should slide in perfectly. And then we'll shift it down, and then num also gets shifted down. Oh, this actually doesn't work because num, the top half of it, stores MSB. Yeah, I'm realizing now the only way to make this work is to just calculate the value. So we can just change I. I will now just be power. We're basically just going to do decoded plus equal. Oh, we'll let power equal to 9 minus I. So you want, actually, no, we want to start at the beginning. So actually, I can be, yeah, I can just stay as it is. Say decoded plus equal 2 times pretty much num and 1 times 2 to the I. So the code will start at 0. We'll do num and 1. If that's a 1, if that is a 1, we'll get 1 times 2 to the I and calculate those values. And then from here, we're going to want to bit shift num down 1. Ah, 5, 12, and 5. That's what you love to see. So there were some intricacies to this that I just didn't think all the way through. So now we can comment out this top array because the values are coming out correctly. Now when we go through the array, the value should be stored because we're going to say num sub I is going to be equal to encode MSB all right, but to do that we'll have to decode the LSB out of num sub I. And that's probably why I put that out there. Decode LSB and now we want to say nums sub so decoded LSB, right? We want to encode, because we're calling encode MSB. This is the value that's going to receive the encoded MSB value. It's going to be num sub decoded LSB. So we decode 5. We want to encode into 5 nums sub 5, which would give you 4. What if we just print the decoded LSB? Decode LSB and MSB are giving me the same thing. Something is just off here. I feel like what I'm calling... Oh, wait. Actually, I might be looking at the wrong array. I think I'm printing nums. So, actually, let me just print this as normal. Okay, now I can't even read this properly. What if instead of these weird functions, we just did console.log.map nums dot, and we'll do decode LSB, and then for this one we'll do decode MSB. That way we can just read it in one line. So if we decode the LSB, we get 5, 0, 1, 2, 3, 4, which is perfect, which means decode LSB is working, which is the input array. Now decode MSB should be the goal value. but instead we're getting nonsense. So what this makes me think is what this makes me think is encode MSB. The most significant bit and the most significant bit side, which is really just 9 bits after the original, we're going to say decoded LSB, which is the source value. Decoded LSB. So we say so the encode, we take the encode, we bit shift it to the left 9 bits, and then we do encode or num to pretty much fuse the numbers together, and then we return it. That's how we encode. It works up here when you're able to decode. Perfectly fine. I think there's a contract issue here. Maybe we shouldn't. We decode it. I think there's a contract issue here. The functions are written so that it works in a very specific way, encoding and decoding. But I think when we keep replacing the values, we end up with a wonky mess because we're not using the functions in the correct order. For example, if we do num sub I, we should get 5. So let's just try and work this out normally. We have 5, 0, 1, 2, 3, 4. In fact, let's just do it a smaller array. The output for this array would be what goes in index 1 is actually index 2, which would be 1. What goes in index 0 would actually, index 2 would actually be index 0, which is 2. What goes in index 2 would actually be index 1, which is 0, which is 0. Okay. So we'd say decode LSB equals decode LSB num sub I. We say if we decode LSB from num sub I, we should get 2. And then I'm just going to return an empty array just so we stop. Oh, it's not going to be 2 because our input is different. But I'll change the test case to be so we do get 2. So decoded LSB would be 2. Decoded LSB would be 2, which is good. Now we'd say num sub I is equal to encode MSB, decoded LSB, which is going to be the source, which is 2, and nums sub decoded LSB, which would be nums sub 2, which would actually give you 1. Now basically, if we look at encode MSB, we have the number 2, and we pretty much want to encode 1 in it as well. So I'll move this to here, and if I do print bits num sub I, we should just get 2 bits turned on, about 10 bits separated from each other. So yeah, I see the problem now. We only get 2 saved, so encode is a little funky. So what we do is we take the encode, which is 2, we shift it 9 bits over, and then we do encode or num, then return encode. I feel like that should work though. So even it's here, it says encoding 0 and 2. Why is it 0? Why is encode 0? If we do nums sub decoded LSB, 2, 0, 1, 2, nums yeah, why is this Z? Oh, well, no. The second index in the original array would be 0, 1, 2. So it should be 1. Do I have an I'm just realized, do I have an extra nums here that shouldn't be here? Oh my god, we already fixed it. We literally just had an extra nums, which was garbling our output. We did have to fix that decode LSB function though, but that is unfortunate. I think we can just now return I guess I would presume it would be the wait, no, it's not exactly working yet. We decode MSB, we should be getting the correct answer. Right, so we're not actually there yet. But we're storing the values correctly, because if we P here, if we run decode LSB on the function, we do indeed get 201, which is our input array. It just happens that our output array is actual garbage. So the first case makes sense. We're encoding 1 in 2, right? 1 in 2. Then we should encode 2 and 0. We get encoding 514 and 0. When we take decoded LSB, it is indeed 0. Right? Now we want to encode 514 . We want to encode 514 decoded LSB . Oh wait, no, that doesn't make any sense actually. Decoded LSB is now 0, and now we're encoding 514 in 0. We can't do num sub decoded LSB because the index at that value is not decoded. So we have to run decode LSB on that. And then we get the proper answer. Yeah, I knew it was a contract issue, but I feel like I just kept getting lost in the sauce. This is the correct answer. So we should just be able to return this. So the test case passes. Let's reset the test cases. Something is awry. I was hoping they'd show us the difference in the correct and the incorrect answers. Wait a second. Some of the numbers in this array usually they say what the difference is. It looks like our answers are pretty close. Actually, they're not close at all. What is going on here? Our numbers are just all over the place. Oh no, right. If something happened, our answers would be all over the place. What if we take something like I wonder why this doesn't work. The 79th test case we fail. What's so special about this test? I see. We're not using enough bits. I think what we need to do is use 10 bits. I think if we use 10 bits, because where the value is 512, everything falls apart. If we use 10 bits, we can turn 512 on. And we actually might still need more bits as we go up. So you might have to. No, actually, yeah, I think this might be fine. But I think we only had no. Let's try adding a bit. I think that's what the issue is, though. Oh yeah, so we seem to pass now. I feel like we might need more bits though. Oh no, we're good. Let's go! Feels strong, man. I think we really just unlocked another cheat code, man. I think we just unlocked another cheat code. I would say this problem, bit manipulation skills just multiplied. The value in easies is incredible. Imagine if we got another bit manipulation problem, but it was a medium. I feel like there would have been a whole bunch of stuff, and then at the end, I would have just been like, I would have read the solution and be like, I don't understand why this works because I don't have any of the intuitions. for the beginning to even make any sense. Pretty much the whole print bits function can go. Now the runtime here, our bit shifting operations are pretty fast actually. So we're just shifting 10 and then bitwise OR. But decode LSB is pretty bad. Every time it's 10 bits. It would always be n times 10 in the worst case. Yeah. That is incredible, man. I kind of want to post this solution. I've never felt proud of a solution before. Right, they use the function for this, except we use bits. I wonder if anyone else used bits. We have to add this. Unfortunately, we will not be providing any context. Maybe you can't post unless you actually add context. No, I just can't post. So, I don't know why I can't post, but yeah, I don't know why I can't post. Maybe I've been banned from posting. But yeah, that was an awesome problem. And this is another SQL problem. So we have about 10 minutes left. We have min cost climbing stairs. You are given an integer array. You are given an integer array cost where cost sub I. You're given an integer array cost where cost sub I is the cost of the ith step on a staircase. Okay. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from the step with index 0 or the step with index 1. Return the minimum cost to reach the top floor. So cost equals 10, right? The cost to take each step. You can either stop at the 0th step or the 1st step. From there, you can either climb 1 or 2 steps. We need to return the minimum cost to reach the top floor. 15. So if the index, if you go out of bounds, basically, you're good. If you don't, then you have to pay the price. Start at 1, you can take 2 steps, 2 steps. 1 step to get the shortest. I was going to say we could visualize the problem as a graph and just do BFS, but that's an undirected. I mean, that's for an unweighted graph. I think I know how to do that. This would be weighted technically because we want the path. We want the the smallest weight path. Well, how many steps are there? Okay, so I was going to say we could brute force it with recursion, but 999 is way too high. I mean, cost.length is way too high. Shortest path. We should have kept reading the ADM. Stopped reading the ADM. And now look at us. So I need to read on shortest weighted path. We know the entire length. Taking a greedy method, which would be taking the shortest path, the smallest option at every turn, would not give us the best path because there's an optimal solution every time. But it would not give us the shortest path. Shortest weighted path. I don't think even in the mediums we've never done a weighted graph problem. A weighted graph problem. Weighted graph parabola. Shortest weighted path. I think the way that I'm viewing it might make this problem more difficult than it is, because I see it as a graph problem, but I don't think it has to be one. There's probably a simpler solution, which is why they labeled this an easy. Given an integer array cost, where cost sub I is the cost of ith step on the staircase. It's giving me climbing stairs vibe. Now, why doesn't climbing stairs work? You get an integer array cost, or cost of I is the cost of the I step on a staircase. Once you pay the cost, you can either climb 1 or 2 steps. If you go out of bounds, you're good. Let me just try a quick solution. I'm pretty sure this would take you out of bounds. I'm pretty sure this would not be ideal. So we'll just say this is going to be an array of numbers, and we're going to say climb. We're going to pass in 0. We're going to pass in sol I. And then we're just going to say if index is greater than sol.length, what we're going to do is say that's a good thing because we reached the end, and we'll say sol.push wait. I'm sure we could memoize this. Otherwise, we're going to say climb sol index plus 1. And then we can actually just start them with actually no. Start them both at 0. And then when you climb on the index, we'll say wait plus sol sub index. You can climb 1 or 2 steps. Right, the step with index 0, the step with index 1. I'm pretty sure you get time. Oh God, what am I doing? I want to do something more like this. Otherwise, this ends up running forever. Yeah, I figured this wouldn't work. I don't know why I tried it anyway. Not even a number. That is strange. Oh, I think I see what's going on. I need to pass in cost as well. What am I doing? We saw push, but we want to actually do I output is 10. We need to, yeah, it's a wrap. We'll come back to this one tomorrow with a better head